Assalamualaikum and salam sejahtera. Here is our last lecture for chapter 8. In this lecture, we are going to learn how to solve the first derivatives implicitly. So far, differentiation has been done involving functions in the form of y equal fx, which is said to define y explicitly as a function of x. For example, y equal 3x squared minus 7x plus 1 and y equal e power x minus 3 ln x squared plus 1. An implicit function is one in which a relationship between x and y is given without having y as an explicit or clearly defined function of x. Y is defined implicitly as a function of x. For example, y squared minus 3y x cubed equal x plus 1 and y zx minus y squared equal 6. An implicit function involving y and x can be differentiated with respect to x as it stands. To differentiate y with respect to x, we write d dxy equal dy dx. To differentiate y power n with respect to x, we get ny power n minus 1 dy dx. Here is how to prove to get the answer. Okay, if y equal fx and y power n is equal for x power n, when we differentiate y power n, also we have to differentiate fx power n. Then we have to use the chain rule to get n fx power n minus 1 times with f prime x. After that, we substitute fx and f prime x, we get ny power n dy dx. In general, to differentiate a function of y with respect to x, first we differentiate with respect to y and then we multiply with dy dx. For example here, suppose we want to differentiate the implicit function for y squared plus 4x equals 6x squared plus 3y. First, we have to differentiate each term of the equation with respect to x. Okay, we can write d dxy squared plus d dx 4x equal d dx 6x squared plus d dx 3y. Then what we get is when we differentiate y squared, we get 2y dy dx. We differentiate for x, we get 4. We differentiate 6x squared, we get 12x. And we differentiate 3y, we get 3 dy dx. After that, we collect all the term with dy dx on one side and without dy dx on the other side. After that, we factor out dy dx, we get like this. And the last one, we solve for dy dx. So what we get here is dy dx equal 12x minus 4 over 2y minus 3. Now look at the first example. Find dy dx in terms of x and y. Given x squared minus y squared equal 8. First, we have to differentiate each term of the function here. So we write d dx, meaning that we are going to differentiate with respect to x for x squared minus we differentiate y squared with respect to x equal, we differentiate with respect to x for the constant. Then what we get here is differentiate with respect to x for x squared, we get 2x minus, we differentiate with respect to x for y squared, we get 2y, and don't forget to multiply with dy dx. And when we differentiate with respect to x for the constant, we get 0. Then we put the dy dx at the left hand side, and then without the dy dx at the right hand side. So what we get here is 2y dy dx equal to x. After that, we solve for dy dx equal 2x over 2y, and then we can simplify to get x over y. Next, we proceed to another equation. Here we are given x cubed plus y cubed equal 2xy plus 8. First, we have to differentiate each term of this implicit equation. So here we write d dx for x cubed plus d dx for y cubed equal 2xy, 2 as the coefficient for the xy, then 2 we just write, and 2 is remain the same, and we just differentiate x, y. And then the last term is differentiate 8. After that, we get the answer for differentiate x cubed, we get 3x squared plus differentiate y cubed, we get 3y squared, and don't forget to put dy dx equal 2, and then we have to differentiate xy here. We cannot use the basic rule to differentiate xy, but we have to use the product rule. I hope that you still remember the formula for product rule. When we have u v prime is equal u v prime plus v u prime, then we have to let u is equal x and v is equal y. So we have to find the u prime here is 1 and v prime here is 1 times dy dx. Then we substitute into the product rule formula. Here we get u v prime is x times with dy dx plus y. Okay, and then we plus with differentiate the constant, we get 0. So we simplify in the bracket first. We have 2x dy dx plus 2y, and the left hand side we just rewrite the terms here, and then we are going to put the terms with dy dx on one side and the terms without dy dx on the other side. So I get here is 3y dy dx minus 2x dy dx equal 2y minus 3x squared. After that, we factor out the dy dx. Here we get 3y squared minus 2x is equal 2y minus 3x squared. After that, we can solve for dy dx. We get 2y minus 3x squared over 3y squared minus 2x. Because of we cannot simplify all the terms here, then we can leave the answer like this.